let's continue then with the rest of chapter 9. So far we've done hypothesis tests and confidence intervals for the mean of one sample. And so today we're going to finish off the chapter by doing hypothesis tests and confidence intervals, but for the means of two samples. Okay. So last week we did hypothesis tests and confidence intervals for the mean of one proportion, and we also did hypothesis tests for the not the mean of one proportion. I'm sorry, for samples. Okay. Last week we did confidence intervals and a hypothesis test when we had one sample and we were dealing with one proportion. Then we also did a hypothesis test when we had two samples and two proportions. And we said, is there a difference between the proportions? Today, when we're dealing with means, meaning we're dealing with quantitative variables or numeric variables, we're going to do the same type of thing. We've got one sample, and then we also have two samples. And when we have two samples, we are comparing the means and saying, is there a difference between the two sample means? Okay, not between the two sample means, but based on what we see in these sample means, is there a difference between the respective populations? So for example, a classic example, and maybe too simple, is that we could say, is there a difference between the average height of men and the average height of women? Okay. And we know the answer to that is what? Yes. We know on average, okay, the average height of a man is taller than the average height of a woman, okay? We know that. That's a fact, okay? Now, of course, if you pick one individual man and one individual woman, it's possible that the woman is taller than the man, okay? That's possible. But overall, as a whole, if we look at the average height of men and the average height of women, the average height of men is taller than the average height of women, okay? The way confidence intervals and hypothesis tests work would be, let's say you were an alien from another planet and you came down to the United States or Earth, and you had no idea about the average height of men and women, okay? So you said, but your alien overlord says, you know, go on this mission and find out. I want to know if the males are taller than the females. And you're like, what is a male? Okay, but somehow you learn, and you pick, and you randomly select, let's say, 20 men and 20 women. Okay, and then based on the samples, so let's say the 20 men have an average height of 5'9.5", okay, and the women have an average height of, let's say, 5'4", okay. We ask, is this evidence that men are taller than women? So there's basically a 5.5-inch difference between the sample mean of the men and the sample mean of the women. Is that evidence that men are taller than women? Okay, and that's what we're going to do. We're going to do confidence intervals for that, and we'll also do a hypothesis test. And that could apply, so whether you are an alien from another planet investigating the difference between the heights of men and women, it could be maybe you are a researcher from the United States and you want to know, is there a difference in the heights of, you know, the men in Sweden and the men in Norway, okay? Maybe you want to know that, okay? Or maybe you want to know, is there a difference between the average weight of navel oranges and Valencia oranges? Huh?
No oranges.
No oranges, you hate oranges, okay? Or is there a difference between the average average time it takes for a man to take a shower and the average time it takes for a woman to take a shower, okay? Whatever. If you want to compare the averages of one group to the averages of another group, this is the test that you use, or the confidence interval that you use, okay?
Is it only between different groups?
Yes, okay? If it was not between, so this thing, it has to be the average of one group versus the average of another group. If you only had one group, what do? We do what we did right before the break, okay? We are testing if the average of this one group is different from some set number, In this case, the set number was 5 ounces. And when we took a group of 30 tomatoes, the average was 5.9. Is this average evidence that the average weight of tomatoes is different from this set number of 5? Okay. Other times, what we will see in this section of the class is we've got 2 groups. The groups have different averages. Is that evidence that the respective populations are different? Okay. So do we care which we do first, confidence intervals or hypothesis tests?
Confidence intervals.
Confidence intervals, you got it. Erasing the board, this is my favorite part now.
The camera center.
I sure hope so. Okay, so we'll say confidence intervals for a difference between means. Okay? Or means of 2 samples. Means from 2 samples. Okay, so
I have a quick question before we start.
sure.
For doing this, is it left to us to choose whether we want to do a confidence interval or a hypothesis
No.
for the different reports?
I will tell you,
You'll tell us.
do a confidence interval or do a hypothesis test, okay?
Okay.
At least in this class, I will tell you what to do.
That was my question, like, not in this class.
Okay, yeah, not in this class. So not in this class, you can choose one or the other. In
Okay.
some cases, it makes more sense to go with a confidence interval. Other cases, it makes more sense to go with a hypothesis test. Basically, anytime you have a preconceived notion of how something should be, do with the hypothesis test. If you're going in basically with no conception of what things will look like or what they should be, do the confidence interval. Okay? But if you have an idea of how things are supposed to be, do the hypothesis test.
So these are just 2 different ways to get at the same answer?
Not the same answer. Well,
Or to get to the same
it's,
conclusion?
there are 2 ways to analyze data and make inferences. Okay, so don't say
Okay, this is
sometimes
what
you get the same answer, but it's 2 ways to approach the data. Okay.
Okay.
Do you have an idea of what things are supposed to be like? Do the hypothesis test, or do you have no idea and you just want the data to speak for itself? Do the confidence interval. All right, so here we want to know what is the true difference between means. The true difference between means. Okay, so means of the respective populations. Okay, so here we are talking about the means of the respective populations. So here we are making a confidence interval for the quantity mu1 minus mu2. This quantity. Alright, so if we made a confidence interval for the difference between the heights of men and women, the true value, this mu1 minus mu2, is the true difference in average heights of men and women. So what might that number be? What's a plausible value for mu1 and mu2 if we were comparing the heights of men and women?
72.
Not 72. That would be
4.5 inches.
okay. 4.5 inches, 5 inches, 6 inches. These are plausible values for the difference in the average height of a man and average height of a woman. Okay, so 72 inches might be a plausible value for the average height of a man, but it's not a plausible value for the average, the height difference of a man and a woman. Okay, so this would be, so something like 5 inches or 6 inches is a plausible value for mu1 minus mu2, meaning the average height of a man minus the average height of a woman. Okay, so let's say we take a sample. Okay, so 2 samples. Okay, so let's say we sampled men, 20 men, and my standard deviation, let's say it was 3.2 inches, and the average height, my X bar, was 70 inches. Okay, and then we took a sample of women, and let's say we sampled 15 women, and my standard deviation was 3.0, and the X bar, let's say, was 64.5 inches. So I'm going to say make a 95% confidence interval for the difference between average heights. What do you think goes in the middle? What goes in the middle of my confidence interval?
Critical value.
No.
X bar.
Oh, the middle.
Minus X
Middle.
bar of women.
Yeah, the X bar, the average height of men minus the average height of women. That's going to go in the middle
Center.
of my confidence interval. This is the center here. Okay, so the center here, X bar 1 minus X bar 2. In this case, X bar of the men minus X bar of the women. Alright? And then what do you think the next part is going to be for a confidence interval? Plus or minus the plus or minus the margin of error. And how do you think we're going to figure out the margin of error?
Twice whatever you did before.
No, it's been the same every single time. What is it?
Critical value
Critical value
times standard
times the standard error, okay? The margin of error for all these confidence intervals have been the critical value times the standard error. Okay? So my critical value, what table will I use here? The t-table. I'm dealing with means, I'm going to use the t-table. Okay? We have to figure out the degrees of freedom. So the degrees of freedom is going to be n minus 1, but which n do I use?
Smaller.
I use the smaller n, exactly. Okay, so in this case, how many degrees of freedom do I have? 14, okay? So my critical value comes from the t-table. Okay, it depends on my confidence level, and the degrees of freedom is equal to n minus 1, and we use the n of the smaller group. Smaller group, or the n with the group with fewer items, okay? Group with fewer people. in this case, my degrees of freedom is equal to 15 minus 1. I have 14 degrees of freedom. If I said make a 90% confidence, oh, I said 95% confidence interval. Okay, 95% confidence interval, what is the critical value that I use? .95% confidence level.
0.025. I mean, 0.05.
No.
145.
2.145. My T star is equal to 2.145. My 95% confidence level with 14 degrees of freedom is
Okay.
2.145. Alright, so the standard error, I'm just going to give you a formula to use for the standard error of a confidence interval with two means. It's just this ugly thing. We just got to deal with it, okay? There's nothing we can do about the standard error formula here, but standard error when it's two means, it's S1 squared. So this is the standard deviation of group 1 squared divided by the sample size of group 1 plus the standard deviation of group 2 squared divided by the sample size of group 2. We add those two together and we take the square root. That's my standard error. And we use that to create our confidence interval. Okay? So if you got a calculator, try this out. See if you can get the number I get, because yes, part of statistics is unknowing the situations and being able to figure out the situation. That's the key part, okay? But another part that's important is being able to do the calculations and being able to do things on your calculator. So for here, I'm going to plug in 3.2, that's the standard deviation of the men, divided by the sample size of the men, plus the standard deviation of the women, 3.0, divided by the sample size of the women. Quantity I get, .0545. So make sure you can get that on your calculator. So what I recommend is doing the inner part, and you can do this all in one step if you got a scientific or graphing calculator, and then hit enter and then do the square root of that answer. And you should get that. Alright, so let's put this all together. So x1 bar minus x2 bar goes in the middle, plus or minus my critical value, my T star, times the standard error, which in this case was that ugly thing. So I'm going to put in 70 minus 64.5 plus or minus 2.145 times my standard error 1.0545. So this quantity over here becomes 2.26 or 2.262, and this quantity over here becomes 5.5. Is everyone good so far? So I say 5.5 plus this gives me 7.76 and 5.5 minus that gives me 3.24. So this is my 95% confidence interval for mu1 minus mu2. Yes?
Is there a rule for which mu to subtract from the other, or is it always smaller from larger?
It doesn't matter. It doesn't matter. Okay. And I will explain this in a moment here. Okay. So the interpretation here, okay, mu1 in this case was what? No, that's x bar 1. What is mu1? Mu1 represents what?
The population.
The mean height of men. And mu2 represents the mean height of women. Okay? So this is how much taller is a man versus a woman. Okay? So here I would say I am 95% confident that the average height of a man, the average height of men is between 3.24 inches and 7.76 inches taller or more than the average height of women. Okay. I'm 95% confident that the average height of men is between 3.24 inches and 7.76 inches taller than the average height of women. What would happen if I had switched the labels group 1 and group 2? Okay? Because these are arbitrary labels. Here I said men was group 1 and women were group 2. But equally valid would be women are group 1 and men are group 2. These are just arbitrary labels. If I had done that, what would change in this thing? I would do 64.5 minus 70 instead of 70 minus 64.5. And then my answer would become negative 5.5. Would my critical value be different?
No.
No, critical value would be exactly the same. Would my standard error be different? No, okay? I mean, basically, these would switch positions, but overall the number would still be exactly the same. So the only thing that would change would be this thing would become negative 5.5, and if you do the plus or minus there, if you had switched them, you'd get negative 3.24 to negative 7.76, okay? So what does that mean, okay? Well, your interpretation there, if you wanted to follow the same form, would be I am 95% confident that the average height of women is between 3.24 and 7.76 inches what? Less or shorter than the average height of men. Okay? Because now we are doing the height of women minus the height of men, but we're getting negative numbers. So I would say I'm 95% confident that the average height of women is between 3.24 inches and 7.76 inches less than the average height of men. We're saying the exact same thing, except one says men are taller than women, and the other person's saying women are shorter than men. Okay? And that's fine. Okay, there was a question though.
The critical value symbol was a C star or?
T star. T star. Why is it T star? Because we're using the T table, and we use the T table anytime we're dealing with means. We use Z star for the critical value when? For proportions. Proportions. For categorical variables, proportions, we use Z star as the critical value. Okay, these are important details. They're very important details. Don't just say, oh, use a T or a Z. No. Okay? Means, use the T. Proportions, use Z. Okay? But the overall concept, you put something in the middle, which is basically what you're getting from your data, plus or minus the margin of error. margin of error is always a critical value times the standard error. Alright. Is this okay? Alright, so then let's say, for the interest of time, let's say we did another confidence interval. But this time we did we looked at men from California versus men from Texas, okay? And let's say, you know, we got X bar and S and the sample size, and we have these numbers, okay? So let's say this was 70, and over here we had 69.8, and so let's say, anyway, let's say we did all of this in our 95% confidence interval is negative 2.1 to 2.6 inches. Okay, so this is my 95% confidence interval. So I would write, I am 95% confident, what? That the average height of men in California is between 2.1 inches shorter and 2.6 inches taller than the average height of a man from Texas, of men in Texas. Alright. Is that okay? So then, would I say, if I asked you the question, do I have evidence that there is a difference between the average height of men in California and the average height of men in Texas? Well, do we have evidence of a difference? The answer is actually no. The answer is no, we do not have evidence of a difference.
Right, because that value's in the range. 6.
Hang on, okay. The reason is because my interval goes from 2 inches, I'm confident that men in California are between 2 inches shorter, 2.1 inches shorter and 2.6 inches taller than men from Texas. So what does that mean? Do I know if men in California are shorter or taller than Texas men? No. If 0 is in your interval, if 0 is in your interval, you do not have evidence of a difference between the means. Okay? And that was the same rule that applied when? Confidence intervals for proportions, right? If we had 0 in the interval then, there was no evidence of a difference between the proportions. So anytime you've got 2 samples, okay, only when you have 2 samples and you're creating a confidence interval, if 0 is in your interval, no evidence of a difference. But if 0 is not in the interval, you do have evidence of a difference. So for confidence intervals, of 2 samples, Is that good? Alright, okay, there's something, an administrative thing that we have to do, and I forgot, is we have to do, course evaluations. So I'm gonna pause the camera, and then, we'll do the course evaluations, and then we'll finish up our lecture here, okay?